You probably know this fact that if you take any number bigger than 1 and take big enough powers, it'll get as large as you want. For instance, if you give yourself a 30% raise and you do this over and over and over again, you're going to have as much money as you could ever want. That would even work with a 1% raise. Of course, it'd be a lot faster if you got a huge raise like this. We could use logarithms, for instance, to see when this power is going to be bigger than, I don't know, 1,000,000. But what if you don't know what a logarithm is? What if you're in a class like real analysis where you have to prove everything and you haven't yet even defined what exponentials are, let alone logarithms? Here's a sketch of a proof that starts just by doing some examples with second, third, fourth powers, etc. These are things we can just expand, and if you notice the clear pattern, you see those exponents showing up as the first term we have here. Now this is kind of me being lazy by just writing stuff, but what's important is if we start with a number bigger than 1, then when we write it as 1 plus p, p is going to be a positive number, and all the stuff here is going to be positive. And so no matter what exponent we put here, we're always going to have at least 1 plus n times p, probably with more stuff. But now if we wanted, say, 1.3 to the n to be bigger than 1,000,000, but by what we just saw, that's going to be at least 1 plus n times 0.3. And if we want that thing to be bigger than 1,000,000, well then the thing we started with is definitely going to be bigger than 1,000,000. And this is something we can solve for just using subtraction and division. We don't need any fancy logarithm. If you go back and think about what would change if instead of 1.3 we had 1 plus any other positive number, and if I changed 1,000,000 to some other arbitrary number, all of these details could be ironed out. And that's why all of these things go to infinity.